An examination of various type 2 and type 3 aiglets and possible manufacturing processes in the production of replicas, presented by Gerald A. Livings. I will be talking about what are type 2 and 3 aiglets and some of how they were manufactured. I will be focusing on aiglets from the post-medieval era, which encompasses the Tudor dynasty. What are aiglets? Well, they are the little things on the end of your shoelace that keeps it from fraying. Not only for shoes, before buttons were regularly used, points were used to hold your clothes together and your pants up. If you had a point, it most likely had an aglet of some sort on each end. I took it upon myself to try and simplify the definitions for aglets. These are the current definitions using the one common characteristic that type 1, 2, and 3 aglets all have in common, a seam. In defining the common characteristics of aglets, it became clear that there were aglets that did not fit into the above system of classification. Today, we are just going to talk about type 2 and type 3 aglets. Type 2 aglets, straight or tapered, they will have both sides of the seam turned in to hold the lace, as you can see here in this slide. Many have rivets as well to help secure them to the cords. I have seen a couple on finds.org that suggest the tops were compressed, but the images were not clear enough to determine this for sure. And type 3 aglets can be unrolled. This definition from XArc is a very good explanation of experimental archaeology. By doing this, we will better understand how they were made, and this will help us in determining later how the materials moved in markets of that time. I have chosen several copper alloy aglets for testing. Most of all of these were found while mudlarking the Thames River in London. It is possible to determine the composition of the aglets, the cordage inside, and the possible adhesives used inside the aglets. This still has to be researched. I used gum arabic, beeswax, bitumen, and pine pitch with and without any added materials as my adhesives. With the exception of gum arabic, all of these materials were eliminated as possible adhesives due to having to work quickly while they were hot. The tools used vary from hand-forged tools to use while replicating the aglets to scientific tools to identify materials. Brass is a copper-zinc alloy, meaning it's made by combining copper with zinc in different proportions. The more zinc, the stronger and easier it is to work with. Think about bending and shaping. The zinc percentage also affects the color. More zinc gives a dull yellow tone, while less zinc leans towards a reddish hue. Bronze is an alloy consisting of copper with tin. No tin were found in these aglets. You can see the copper and zinc in this plot from the scanning electron microscope. You can also see carbon, silica, zinc, aluminum, and oxygen. The aluminum is probably a contaminant or a false reading from the microscope. The silica and carbon are probably from sand on the surface of the aglet. ATR, attenuated total reflectance Fourier transform infrared spectroscopy, is a non-destructive, fast, and convenient method often requiring minimal sample preparation. With a micro ATR accessory, it is possible to use very small sample sizes, and the IR spectra can be measured directly from the sample surface. Micro ATR testing did tell us a little bit about the chords. I was not successful in determining the adhesives. This is one example of many of an anvil made specifically for making aiglets. I made my aiglet anvil using this as a guide. Here are some of the tools I made and used. Using tools that are error correct lends credence to the experimental results in my opinion. Here you can see my anvil in use. You can also see on this image how the seam is made by folding in both edges of the metal to make a type 2 aglet. A type 3 aglet has only one side folded in and then it's rolled up, just like a piece of paper. The cord in this image is wool. I was unable to determine what the resinous material was. In my experiments, I used cotton shoelaces and gum arabic as the adhesive to help stiffen and hold the cord inside of the aglets. Native float copper from Michigan State was used to avoid any possible contaminants or alloys from using recycled copper. Confounding variables need to be addressed in every experiment. I should have forged this metal out on a hammer with a hammer and an anvil, but I have a damaged shoulder, so I used a rolling mill to process this metal. I do not feel this would drastically alter the results. The slot at the end of the anvil is just under 2 millimeters deep. You can see here from the scribed mark just how deep it is. You can see how this would help with making a uniform bend for every aglet made. Using the cut-in slot to pre-bend the copper blank, this is more efficient than trying to bend these with pliers. Here you can see the pre-bent copper blank. You can see that it is quite open. I had to bend this over a little bit more with a burnisher to get the smaller curve. I will be grinding a bit of metal off the end of the anvil so I can get a sharper initial bend with just the anvil. Before sliding the cord into the metal, I added my adhesive material to the cord. Here it is just enough gum arabic to dampen the cord. The other materials used were much harder to use and were hard to use as soon as they cooled off. They resisted bending the metal. The cord used were all cotton shoelaces that were woven round but flattened out nicely. Here you can see me burnishing down the copper seam to secure one side of the cord. Here you can see the cord gripped easily by the copper seam. At this point, you need to decide if you are making a type 2 or type 3 aglet. The decision to make a type 2 aglet means you cut the metal strip about 3 millimeters from the far side of the cord, so you can use the end of the anvil to make a second curve to hold the cord before you do the final bending. If you're making a type 3 aglet, you want to cut the copper about 2 millimeters from the far side, so you have just enough to wrap around the aglet. Folded for a type 2 aglet, all you need is to catch the cord on each edge, not a huge amount. If you make the curves too large and have too much metal inside, you can't make a round aglet. It ends up just folding the metal and the seam does not want to close up nicely and it doesn't look really nice at all. Using the hammer and various half-round depressions in the anvil to round up the aglets. At this point, pun intended, you will have a cord with a finished aglet. Now repeat on the other end of the cord to finish making your point. This is a flat 6-cord wrapped flat ribbon made from cotton embroidery floss with copper type 2 aglets. I made this myself. You can see how it looks just like a shoelace. I was able to determine the metal content and alloys of several aiglets, but was unable to determine what possible adhesives were used. Through the process of experimental archaeology, I was able to narrow down the process to make type 2 and type 3 aiglets. It takes about 4 to 5 minutes to efficiently make type 2 and type 3 aiglets when either using round or flat woven cords and ribbons. It was also easier to use the thinner copper of about 0.12 millimeters to form the aiglets. Being thinner, it had fewer problems with work hardening. Thin sheets of commercial brass work hardened too quickly and required a lot of additional effort to make the edges smooth when making type 3 aiglets. It was also harder to get a uniform roundish shape to the type 2 aiglets with thin commercial brass. I believe that with practice, this time for assembling a finished point can be reduced to less than 4 minutes total. Add in the time to source and produce the thin metal sheets needed for type 2 and type 3 aiglets, and I feel that with economies of scale, it might be possible to create a single point within 5 to 6 minutes. This is within the time frame that I feel is acceptable for the mass production of these ubiquitous items of everyday clothing during the early medieval, medieval, and post-medieval eras. Further research is warranted in this field of study. Experimental archaeology was used to test the conjectured manufacturing steps for different types of aiglets and gives weight to the offered hypotheses. The tools and techniques to make aiglets are very similar to those used by jewelers of the past and today. More research is indicated to continue this line of questioning. I want to make clear that AI was not used in any way for this paper or presentation. Thank you for coming to or viewing my presentation. As I learn more, it will be added to my website. If you have questions, comments, or would like to suggest an area of study, please email me at the email address above. Now, any questions?